Hello everyone, in this video I'm going to talk about the client-server model, or sometimes referred to as the client-server architecture. I'm going to start off by drawing some really simple diagrams and keeping it very broad and at a high level, and then as we progress through the video I'm going to go into deeper detail. I'm deliberately leaving some of the in-depth detail out of this video because I want this to be a high-level overview, but if you have any questions leave a comment down and I'll make sure to get back to you. So let's start off by just thinking about our client and our server. So we can think of our client and server as two machines. So this is my client here on the left and this is my server on the right. And my client makes a request because my client wants something. So we represent this with an arrow and this is our request. So after my client submits their request, the server has to do some processing. So maybe it decides whether this is a good request, so if that client is actually eligible to get a response. Otherwise the server might say, no, I'm not going to give you what you requested and I'm going to give you back an error message saying that you're not allowed to have it, or I couldn't find what you're looking for. But let's assume in this scenario that whatever the client requested, they are allowed access to it. So my server here, represented by an arrow, would give whatever data the client had asked for. So this could be a HTML web page, this could be maybe an audio file or a video file, anything at all. It could even be some sort of JSON or XML. But this information is what the server gives back to the client, and we call this the response. And that's what a lot of this architecture or model is based around: requests and response. So the client makes a request, the server gives a response. So what exactly is a client? Have you ever used Google Chrome or Firefox? Maybe if you're on Mac you've used Safari, or on your iPhone you may have used Safari. You might have even used Internet Explorer. If you've used any of these are all web browsers, and the web browser is the software that we interact with as users to go and get the information that we want. So let's assume we've got our laptop, and on our laptop or computer we have an internet browser installed, such as Google Chrome or the other ones that I mentioned, and we go to the address bar. So we want to type in something, we want to search for something. So let's assume that we put YouTube into our address bar. So if we go and put YouTube into our address bar, that request is sent off to the server, and the server gives back a web page, our web page being YouTube. Now there's actually an additional little step. This isn't quite right, but I'm going to go into a little bit more detail now in a couple of minutes. So in this example, when we go and search for YouTube, what we get back is a HTML page, and the HTML page is the YouTube web page that we see. So we see the little YouTube icon in the top left, and we can see the search bar, and we can see, suggested videos for us to watch, and we can go into our YouTube account and so on and so on. But this client server is for more than just web pages. For example, maybe we are not consuming or using the server for watching YouTube or visiting Facebook or something like that. Maybe we are creating our own server, and on our server we have some endpoints. An endpoint being something that serves up data to us. So it could be a simple JSON response that we get. So possibly we go and hit localhost/API/users. And this is an endpoint that we've created on our server, and as a response we get back some sort of JSON information. So you can see in this example we might get back a message like this with a name and a value, in this case Ryan. So these are two different examples using two different formats in a client-server model. One of them, we're getting back a HTML page like YouTube. In our second example, we're getting back JSON. But we could get XML, we could be getting a binary file, we could be getting a video file. If I go back to my YouTube example for a minute, we know that we make a request as a client through our web browser to a server, and then we get served up a page, youtube.com. But for a big website or a big company like YouTube, they wouldn't just have one server. that they have with their HTML sitting on a hard disk. They'd actually have multiple servers. So they might have another server here, another server here, another server here and here, and many, many, many different ones. And these servers might just not be in one location. There might be a server in India, there might be a server in the US, there might be a server in Ireland, and all across the world to serve all the different customers to make sure that the latency is low. Now, if you're creating a website or a web page and you know it's only for personal use or it's only a small project that you're working on, more than likely you're only going to have one server, and that server is going to have a public IP address, and you also have a public IP address that you can use to interact with the server that has a public IP address. So when you're using your local laptop, you might have a local address for it, so it might be maybe 192.168.2. But then when you want to go and make a request, you have to go out to the internet, and to access the internet you need to go through a public IP. So you would then go to your router through your ISP or internet service provider. Maybe you're using Vodafone, maybe you're using Sky or Virgin or Aircom. So your laptop goes to your router, and your router has a public IP address. For this example, we'll say it's 5.5.5.5. And we know the server that we want to get our information from is maybe 7.7.7.7. So you're probably thinking, okay, we go from our laptop to our router, and our router knows that we want youtube.com, so then we just go to the youtube.com server. The only thing is, the youtube.com server isn't called youtube.com. We can't tell our router to go and find the youtube.com server, because as you can see, the YouTube server in this example is 7.7.7.7. So if we go and ask for youtube.com, we wouldn't actually be able to find it. So there's one extra step that we have to go to first, and this is called a DNS. The DNS stands for Domain Name Service, and this is actually another type of server, and we'll say its address is 8.8.8.8. And our router will make a request to this DNS service, and it'll say, hey, look, I know who you are. I'm looking for youtube.com. Could you tell me what the IP address of youtube.com is? And the DNS server has a table, and it has a list of names, so it would have YouTube. Our DNS server will look for YouTube, and it'll say, oh yeah, I have YouTube, and I know that YouTube is at the server 7.7.7.7. So then it sends back a response to my router saying, hey, you're looking for youtube.com. Its address or its location is at 7.7.7.7. So my router says, okay, I need to go and look for 7.7.7.7. So I make the request to the YouTube server, whatever my request is. Maybe I'm requesting to download a file, maybe I'm requesting to view a video or look at a different web page, and then the YouTube server will come back to me with a response. Then my router will get the response and will go back to my laptop or my web browser, Google Chrome or Safari, and it'll receive a response. And then I can go and look at or download whatever I originally requested from youtube.com. So now the next thing you might be wondering is, right, okay, so maybe I want to create my own server. So I'm not interested in, how YouTube or Facebook servers work. I want to go and create a server of my own. So if you want to go and create a server of your own, you need to first of all get a public IP address. And you can do this by going to any cloud provider. Azure is a very popular platform created by Microsoft. There's also AWS created by Amazon, and then Google has Google Cloud Platform called GCS. There's also some other smaller ones like DigitalOcean and a ton more, but these three here are the three main ones. So you start off by purchasing a server off one of these cloud providers, and then once you've purchased a server, you can go and do whatever you want with it. So for example, if you wanted to host a website, you would have to start off by installing some software on it. So more than likely there's an operating system already installed. You would usually pick that during your setup process. So you might choose Windows, or you might choose a Linux distribution like Ubuntu. Then after that you would install your web server software. So you might want to go and install Tomcat. Or if you're going with the approach of using containers, you might go and install Docker on your server. You would then go and install your container and spin it up. So within your container you would need some web server, so that might be Tomcat if you're using a Java application. Another thing that you want to keep in mind is ports. So for example, when you go to youtube.com, you don't put any port number at the end of it. You type in youtube.com. Now, this is because all web traffic is by default sent to port 80. So your web server would be running on port 80. Now, you might realize if you do any local development on your machine, you might run your web server on port 8080, or you might run your web server on port 5000. But if you run your web server on a different port, or you change the default port, the user would have to specify that in the URL. So let's say YouTube changed their web server from port 80 to port 81. Then all users that want to use YouTube would have to type in youtube.com/81. So this is very inconvenient for the user because they have to remember to put in the port number. So if you just keep it at the default port number, port 80, your users will be automatically sent to your website. There's many different protocols. The protocol over the web is HTTP, so this is port 80. HTTPS uses port 443. If you're doing stuff with files, so if you're using FTP, File Transfer Protocol, that would be using port 21 by default. If you're SSHing into a server, you want to change something, that would be using port 22 by default. So this is just something to keep in mind, because if you try and run a web server on a port that's already running, so this might be something that you've run into in the past when you've been working locally, or you have been developing software locally. You have got a service running on port 8080, maybe you've got Tomcat running on port 8080, and now you've opened a new application, a brand new project that you've been working on, and you try and run it, and it's also trying to run on port 8080 on your local machine. And you're going to get an error message saying that you can't run this program because this port is already in use. So then you'd have to go and kill the previous program that's running on port 8080 to run the new program. If you like this and you want to see more, you know what to do.